I've been asked to provide some model answers to the PowerPoint where there were some product rule questions for you to practice with. That's the one that's into three sections. The first two sections aren't so bad, as I understand, but section three, a couple of you asked for some feedback on and some model answers. So I've got some new technology and actually I can show you. These are the questions where actually there's a fair amount maybe of chain rule that's having to go on as you differentiate U and V, but also it's how we simplify the answers. So apologies for handwriting is not great. I'm getting used to this pen tablet that I've just bought myself. So you're going to have your U and your V, and then we're going to differentiate both of them individually. Now it might be that you just need to bob off somewhere else and do it as an individual chain rule question, because you might go, oh, I've got t squared. So if I differentiate the t, I get a cos x. And when I differentiate t squared, I get 2t. So I'm going to put the 2 there and put the sine x next. And then we'll differentiate this one. So I've got t cubed differentiate what's in the bracket there. I'll get a 1. So that's going to be useful. I just times by 1 won't make much difference. And then I differentiate t cubed and I'll get 3t squared. And then with your product rule, I haven't put the formula on here, but you multiply the u with the dv dx and times those two together. And then you'd add that together to the product of those two things, v into u dx. So I do the first sort of pairing. I'm going to have sine x all squared times by 3 lots of x minus 3 squared. And then I'm going to multiply these two things together. I'm going to do all the tricky stuff just in front on this one. Apologies, it just takes ages to write these things out, doesn't it? Okay, and that's the differentiation done. But certainly we want to tidy up. We want to look for some common factors. I'm going to have a go at rewriting my answer. Looking at integers, first of all, I've got 3 and a 2, so a common factor of 1, so there's no point doing that. We've got a sine x all squared and a sine x, so there's a common factor of sine x first of all to take out. And then I've got an x minus 3 squared, so I have a bracket squared and the same bracket cubed. So I'm going to take out bracket squared. Now, actually, I don't really want to write it there because it suddenly looks like a sine of all of that. So I'm just going to change what I was doing. And actually, it would be neater if I have the x minus 3 squared first and then the sine x. So it's definitely sine of x, not sine of anything else. That's my common factors. Open up my squared bracket there, try and write a little bit neater perhaps. There we go. Right, so I need to put the 3 in. We take out all of those brackets there, and I need another sine x. So we're going to have 3 sine x in there. And then the second term, we've taken out the sine x, but we haven't taken out the 2 cos x. But also we have a bracket that we haven't taken out. So actually I should have written that differently there, haven't I? Just done completely opposite of what I wanted to. So I've taken out one of the brackets, taken out the 2 and the cos x, or putting them back in, I should say. And actually that question then is done. I could multiply this out, but there's no reason because there's no sine x terms that I could combine with that one. So I'll leave that as it is. Now I know on the PowerPoint with the answers, they didn't actually take the sine x out, which probably wasn't very good when they're trying to demonstrate lots of good factorising. So second question. Write down your U and your V. And because you're doing product rule at the moment, it's probably fairly obvious which is which, but if you've got two things we multiply together, then that means we're going to have to use the product rule. Now individually, both of these need the chain rule to differentiate. When you differentiate e to the power of something, you get e to the power of something. But you have to differentiate that something, that's the t. So if I differentiate that, I will get a 3. and times those two bits together. So that's my differentiation there of u. And then differentiate into b by dx is going to be t cubed. If I differentiate my t cubed, I'm going to get 3 lots of t squared. And then I have to multiply it by the derivative of the bracket, which is going to be a 3. So perhaps I could have written that straight away as a 9. But I just wanted to show you those 2 steps there. So now I can do my dy by dx times these 2 things together. So I am going to put this one first. I'm going to make that 3 times 3 is a 9. 9 lots of the bracket squared times by e to the 3x. And then add that together, the multiple of these 2 things. So I've got the 3x all cubed. And I need to times by 3 e to the 3x. I'm actually going to put the 3 there and then put the e to the 3x at the end, just split it up. Okay, handwriting's looking pretty atrocious. I'll get better at this pen tablet, apologies. Let's start factorising. So integers, we've got a 9 and a 3, so there's a common factor of 3. Bracket squared, bracket cubed, so we've got bracket squared as a common factor. And both terms have an e to the 3x. So we have 3 kind of separate common factors, an integer, the bracket, or 2 of the brackets, and then the e part. So what have I got to times that by to get there? Well, we've taken out the bracket squared and the e, we took out a 3, so we just need to put a 3 in. Second term, we've taken out the 3, but we only took out 2 brackets, so we've got 1 more bracket to put back in. Putting it in its own little bracket at the minute, especially if it had been a different multiple of 1, I certainly would have wanted that bracket. But there we go, taken out 3, we've now put in the extra bracket, that e to the 3 is taken out, so that last term is factorised. So if I look in my square brackets, this is what I can't use square brackets as a temporary thing, because actually now is there anything that would simplify here? If you get rid of those internal brackets, then there is a little bit of simplifying that could have happened. So we're going to just keep all of this as it was. I'm going to put the e bit last in this one. So actually my square bracket, I've got a 3x. 3 plus the minus 4 will be minus 1. So that's my square bracket. I'll put the e to the 3x back in. So that would be my full answer. Possibly these brackets things might be in a different order, but that is the answer that you will want. So see if that helps you out. The third section of that PowerPoint, they are a bit tricky, so don't panic too much at the minute. You might be a bit hit and miss, or you can just send me a copy of your answers, and actually I can annotate your work now and talk it through with you. So I hope that helps.